Hi students, welcome to our YouTube channel Knowledge Academy. The meaning of this lecture is to discuss about the numerical methods, formulas in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, the direct notifications comes to your mobile. If any improvements in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So now we are going to learn about the numerical methods. See, the first concept in the numerical methods is round of value. So what is the meaning of the round of value means we are going to do some approximation for the given number. Suppose there are two numbers x and y. If suppose y lies between 0 to 4. If suppose the y is going to lie between 0 to 4, then what we are going to do is we are going to replace x by x itself. So whenever this 4, it is after this, suppose there is a decimal point here. So after this decimal point, we are going to get the first number is x, the second number is y. And if y is going to lie between 0 to 4, then put x only at x. Means we have to, see, we don't have to do any changes to the value of x. We have to keep as it is. If suppose y is going to lie between 5 to 9, then put x plus 1 value at x. Means we have to increase the x value 1 by 1. So therefore we can say clearly after the decimal point the values are x and y, and if the number y is going to lie between 0 to 4, then we have to replace x by x itself. Means we don't have to do any changes to the value of the x. But if the value of y is going to lie from 5 to 9, then definitely we have to replace the value of x by x plus 1. So now we are going to learn about the remainder theorem for polynomials. Remainder theorem for polynomials. Suppose there is a polynomial p of x. So I am going to divide this polynomial p of x with d of x. So if you do the division, we are going to get the quotient which is q of x, and the remainder is r of x. So therefore we can say p of x is equal to d of x into q of x plus r of x. Means we can write p of x as which is d of x into q of x plus r of x. And we can see clearly always the degree, or we can say the power of the r of x is always lesser than the degree or the power of the d of x. We always say that, see, always the power or degree of r of x is always less than, it is always lesser than the power or degree of the d of x. Let's suppose d of x is equal to x minus k. If the power of the d of x is x minus k, means here this is the polynomial of d of x is equal to x minus a. So you can see clearly the power of this d of x is 1. So therefore already I told you the remainder r of x power should be always lesser than the d of x. So this power is 1, means this power should be always equal to 0. Means x to the power of 0 means there has to be some constant k. So therefore we can say clearly here d of x is equal to x minus a, means r of x has to be equal to k. So therefore now I have already told you p of x is equal to d of x into q of x plus r of x. But you can see clearly d of x is equal to x minus a. So now in this polynomial I am going to replace x is equal to a. So if whenever in place of x I am going to substitute x is equal to a, then definitely this value will become 0. So therefore 0 into q of x is again 0. So therefore only thing we are going to get is r of x, and you have to replace x is equal to a. So for this equation, if you replace x is equal to a, then you are going to get the value of the k. So therefore this is an easy way to figure out the value of the k from this polynomial equation. Means always you have to keep the roots of the d of x in this polynomial equation, then you are going to get the coefficients of this r of x you can easily figure out. So therefore now we can say that r of x is equal to k. Suppose let me assume the d of x as a power of 2, or we can say the degree of the d of x is 2. So therefore x minus alpha into x minus beta. If its degree is 2, then definitely the degree of the r of x has to be 1, because it is always lesser than the d of x. So therefore I am going to assume which is ax plus b, its power is equal to 1. So now I am going to write in the general format equation which is p of x is equal to d of x into q of x plus r of x, but I have replaced d of x by x minus alpha into x minus beta. So you can see clearly in the r of x there are two coefficient values which are unknown, and we need to figure out the value of the a and b then only we can know the exact equation of the r of x, which is ax plus b. So therefore now what I am going to do is, here in this equation I am going to replace x is equal to alpha. So whenever I replace x is equal to alpha, then this equation will become definitely 0. So with the help of this, we are going to get one equation. And similarly here, in this equation I am going to replace x is equal to beta, and whenever I am going to replace x is equal to beta, again this equation will become 0, or we can say this term will become 0. So therefore we are going to get this equation. So we are going to get two equations with two unknowns. The two unknowns are a and b. So definitely we got two equations with two unknowns. So we can easily figure out the value of the alpha and beta, and we can say we can easily figure out the value of the a and b. So now we can easily figure out the value, which is r of x is equal to ax plus b. So the only agenda of this one is to figure out the what is the value of the r of x with the help of the d of x. Now the second concept is polynomial of degree n. Suppose there is a polynomial p of x of degree n. So you can see clearly, which is a n x to the power of n, a n minus 1 x to the power of n minus 1 up to a to x square a1 x plus a naught. So you can see clearly the degree, or we can say the highest power of a value of x is n. So therefore we are going to call this as a polynomial of degree n, and it is equal to 0. See, whenever there is a polynomial of nth degree, definitely we are going to get n roots. Means if you are going to substitute these roots in this equation, definitely we are going to get the value of 0, or we can say similar, or we can say clearly it is equal to the root. The polynomial equation is going to cut the x-axis. So at these points, so therefore this polynomial has n roots. So now suppose I am going to take a general format of quadratic equation. Suppose I am going to take a quadratic equation which is a naught plus a1 x plus a2 x square. So we can see clearly this is the polynomial of second degree, or we can simply call it as a quadratic equation. Then what I am going to do is, here I am going to take a2 into x minus alpha into x minus beta. See, I can write this equation in also another format, which is a2 into x minus alpha into x minus beta. So if you do the multiplication and if you do the simplification, finally we are going to get a2 into x square plus x into minus alpha minus beta plus alpha into beta. So now if you compare these two equations, we are going to get, which is alpha plus beta is equal to minus a1 by a2, and alpha into beta is equal to a naught by a2. So these are the things that you are going to get, which is alpha plus beta is equal to minus a1 by a2, and alpha into beta is equal to a naught by a2. And similarly, suppose there is a cubic power equation, or we can say if you have a polynomial of cubic equation, which is a naught plus a1 x plus a2 x square plus a cube x cube. So therefore definitely we can say, as the polynomial is of cubed root, it is going to have 3 roots. So therefore now a3 into x minus alpha into x minus beta into x minus gamma. So these are the 3 roots, which are the alpha, beta and gamma. So now if you do the multiplication and do a simplification, finally we are going to get a cube of x cube plus x square into minus alpha minus beta minus gamma plus x into alpha beta plus beta gamma plus gamma alpha minus alpha beta gamma. So if you compare these two equations with the corresponding coefficients of x cube, x square, x and a naught, then definitely you are going to get, which is alpha plus beta plus gamma is equal to minus a2 by a3, alpha beta plus beta gamma plus gamma alpha is equal to a1 by a3, whereas alpha beta into gamma is equal to minus a naught by a3. So these are the things which we are going to get, which is sum of the roots, the product of the roots, and also the product and sum of the two roots. So we are going to get, these are the terms. Means if you know the coefficients of the polynomial equation, then we can easily figure out the what is the nature of this summation, the product and the sum of the product of two roots. So all these things we can figure out only if we know the coefficient of the polynomial. So now I will give you a general way how to figure out the roots of any nth power polynomial equation. Suppose there is a polynomial equation of nth order or nth degree, which is an x to the power of n plus n minus 1 x to the power of n minus 1 up to a1 x plus a naught is equal to 0. So you can see clearly this is a polynomial of nth degree or nth power. Then suppose, see, I already told you, as it is a nth power or nth degree, then definitely it is going to have n roots. So let me assume the summation of the roots. I want to know what is the summation of each and every n roots, which is equal to minus of coefficient of x to the power of n minus 1 by coefficient of x to the power of n. So this is the formula which we need to remember, which is negative of the coefficient of x to the power of n minus 1, which is n minus 1, and the coefficient of x to the power of n, which is an. So this is the formula for this one. Suppose if you are going to take the summation of the product of two roots, then what is going to happen, which is minus 1 whole square, because we are going to do the product of two roots, so therefore 2 square coefficient of x to the power of n minus 2 by coefficient of x to the power of n. So this is always the coefficient of x to the power of n, whereas this one is, suppose if you are taken a minus 1 whole to the power of 1, means here it has to be n minus 1. Here minus 1 whole square means here it has to be n minus 2. Suppose we have taken the product of three roots and the summation of three roots, we are going to get means the summation of product of three different roots, which is minus 1 whole cube, because we are going to take the product of three roots. So minus 1 whole cube into coefficient of x to the power of n minus 3 by coefficient of x to the power of n. Similarly, suppose if you are going to take L roots, suppose if you are going to take the product of L roots, then definitely the summation of the product of L roots, which is equal to minus 1 whole to the power of L coefficient of x to the power of n minus L by coefficient of x to the power of n. So this is the easy way to remember, which is always minus 1 whole to the power of the number of roots which are going to multiply into x to the power of n minus that L by coefficient of x to the power of n. So by this way we can figure out the summation, the product of any number of roots we can easily figure out. So this is a general formula that you need to remember to solve the questions. So now the next one is Descartes sign rule. So now we are going to learn about the Descartes sign rule. Suppose there is a function f of x is equal to 0. Then suppose for this function f of x is equal to 0, then the number of real positive roots, which are always less than or equal to the number of sign changes in f of plus x. See now, suppose there is an equation f of x. In that equation, you are going to replace x by f of x, and then we have to figure out what is the number of sign changes in the coefficient of the f of x. If you are going to see, then the number of real positive roots are always less than or equal to the number of sign changes in f of plus x. And similarly, the number of real negative roots is always less than or equal to the number of sign changes in f of minus x. So definitely, if you want to know a general idea how many number of positive real roots are possible and how many number of negative real roots are possible, you can easily figure out with the help of the number of sign changes in the f of plus x and also the number of sign changes in the f of minus x. So therefore, we can see clearly the number of real positive roots which are always less than or equal to the number of sign changes in the f of plus x, and similarly the number of real negative roots, the number of negative real roots are always less than or equal to the number of sign changes in the f of minus x. If polynomial has all ai rational, then complex roots or irrational roots always comes in pair. Simply it means that suppose if a polynomial, if each and every coefficient of the polynomial has a rational, means if any number in the form of p by q, then we are going to say that number has said to be a rational number. Then definitely if all the coefficients of the polynomial are rational, then definitely always the complex roots and also the irrational roots are always going to come in a pair, which is a plus or minus ib and a plus or minus root b. So this is called as the complex number, and this we are going to call it as the irrational number, or we can say irrational roots. Means the meaning of irrational roots is after the decimals you can't get any number which is a repeating, means always you are going to get different numbers, and always it is not going to tend to a finite number, means it is always going to infinity, means the number is not going to get stopped, it is always going to get infinity after the decimal. So therefore we can say those numbers are said to be irrational numbers. So therefore always the complex roots and the irrational roots are always going to come in a pair, which is a plus or minus ib and also a plus or minus root b. Now we are going to see about the solution of the equation f of x is equal to 0. Suppose there is a function f of x is equal to 0. So if you are going to draw this function with respect to x, definitely at some points this function is going to cut the x-axis. So what are those points I want to figure out? Then suppose if f of x is continuous function, then here if f of a into f of b is greater than 0, if f of a into f of b is greater than 0, it indicates that this is positive, this is also positive, or if this is negative, then definitely this is also negative. Then only we can say this is always greater than 0. Then even roots are possible between a and b. Means even roots means if whenever it has even roots, means 0 or 2 or 4, then only this is possible, which is f of a into f of b. F of a into f of b is always greater than or equal to 0. It indicates that always for this, means between this a and b, definitely there will be a even roots, even number of roots are going to possible. Means it can be either 0, it can be either 2, it can be either 4, or it can be any number like even number. It has to be purely a even number. Suppose if f of a into f of b is less than 0, means if f of a is positive, then definitely f of b must be negative. And similarly, if f of a is negative, then definitely f of b must be positive. Or we can say if one is positive, then definitely the other has to be negative. Then only their product is less than 0. Then definitely we are going to say that here then odd roots are possible between a and b. Means between a and b, odd number of roots are going to occur, which means it can be either 1, 3, 5 and goes on. So therefore, if f of a into f of b is greater than 0, it indicates that even number of roots are going to occur between a and b, like 2, 0, 2, 4 and goes on. If suppose if f of a into f of b is less than 0, means the number of roots which are going to occur in between a and b is always odd number. It can be either 1, 3, 5 and it goes on. Suppose if f of a into f of b is equal to 0, means then at least one of the value of a or b is the root. Means if f of a into f of b is equal to 0, it indicates that at least one of them, it can be either a, it can be either b, or it can be both a and b. It can be anything. So therefore we can say here at least one of them should be a root of the function f of x. So therefore we can say, so we have learned that whenever f of a into f of b is greater than 0, then definitely we conclude that even number of roots are going to occur between the function between the a and b, like 0, 2, 4 goes on. But if f of a into f of b is less than 0, it indicates that odd number of roots are going to occur between the a and b, like 1, 3, 5 and goes on. But if f of a into f of b is equal to 0, then definitely we can say that one of them, at least one of them, is to be a root of the equation f of x is equal to 0. So now we are going to learn about the different ways, the different numerical ways to figure out the roots of the function f of x. Suppose this is the function f of x and this is the graph of the function f of x. And you can see clearly I have taken 2 points a and b. See, I have taken 2 points a and b such that for a the y value which is f of a and for b the y value is f of b. So you can see clearly here one is a positive, the other is negative. So therefore if you do the product, it has to be less than 0. So therefore you can say the order of the bisection method is always equal to 1. So this is a very important point, which is the order of the bisection method is always equal to 1. See, find two values x is equal to a and x2 is equal to b, x1 is equal to a and x2 is equal to b, such that f of a into f of b is always less than 0. Means, see, you have to take any 2 points a and b such that the condition for a and b, which is f of a into f of b, must be always less than 0. See, you must not take any 2 points. See, you have to take only those points which has satisfying this property, which is f of a into f of b is always lesser than 0. Then the first iteration is, which is take the midpoint of these 2 points. For a and b, take the midpoint, which is c is equal to a plus b by 2. Then do the cross check and check whether the root lies, where the root lies, and repeat this process till we reach the root. See, suppose now you have taken the midpoint of the a and b, which is a plus b by 2. Then again suppose there is a point c. Suppose let me assume the c is at this point. See, now with f of a is positive and f of c is also positive, so therefore a root cannot lie between this because it has to satisfy the property, which is f of a into f of c should be less than 0, but it is not going to satisfy. But if you take f of c and f of b is negative and f of f of d is negative and f of c is positive. So therefore, definitely the root is going to lie in this region. So therefore, this is the process that you need to do repetitive manner until you are going to get the root. F of c is equal to 0, stop the process. Means you have to repeat this process until you are going to get the exact root of this function f of x. First take 2 points a and b, then check the condition which is satisfying the property which is f of a into f of b less than 0, then take the midpoint of a and b and again check the and then see whether if it is f of c is equal to 0 or not. If it is not equal to 0, then repeat the process again from the starting onwards. So like this you need to go for the in an iterative manner till you are going to get the exact solution. So this is called as the bisection method. Means we are going to take the midpoint of a and b, or we can say the order of the bisection method is 1. So now we are going to learn about the regular falsie method. So this is a second method to figure out the root of the f of x by using the numerical methods. So suppose there is a function f of x. So this is a graph. Let me assume this is a function f of x. See, the first step in the regular falsie method is find two values x1 and x2 such that f of x1 into f of x2 should be always less than 0. So this is the, see, you have to choose any two values x1 x2 such that this condition is always satisfied, which is f of x1 into f of x2 should be always lesser than 0. Suppose this is the point x1, so therefore this point is x1 comma y1 and this is x2 comma y2. So therefore now you have to choose 2 points in such a way that which is f of x1 into f of x2 is always lesser than 0. So now you can see clearly here, see, this is a point on the graph and this is also a point on the graph. So now it just means you can draw a straight line between these 2 points. So with the help of 2 points you can draw a straight line and you can see clearly this straight line is going to touch a point which is on the x-axis. Let me assume the point here is now x3. So now what I am going to do is, now I am going to find the equation of this line with the help of 2 points and I want to know what is the value of this x3. For this equation, if I keep y is equal to 0, means this line is going to meet the x-axis. So definitely y is equal to 0, then you are going to get an equation which is x3 is equal to x2 y1 minus x1 y2 by y1 minus y2. So this is the equation which we are going to get, which is, so this line is going to meet at x-axis. That point is nothing but x3, which is equal to, here take here y1 y2 minus and here keep x2 and x2. So therefore x3 is equal to y1 y2 minus x2 x1. So in this manner you are going to get the value of x, which is x2 y1 minus x1 y2 by y1 minus y2, and check where the root lies and repeat the process till we reach the root. So now what you are going to do is, so now you can see clearly here f of x1 is positive and f of x3 is negative. So definitely if you do the product, this line is going to, so therefore now suppose if you got x3, now substitute this point whether it is going to satisfy or not. So f of x3 is equal to 0, then only stop the process, otherwise you have to repeat the process. So simply what I am trying to say simply is, take 2 points x1 x2, then always find, you have to choose x1 x2 in such a way which is f of x1 and f of x2 is less than 0, and then with the help of these 2 points draw a straight line and figure out the value of x3 by using this formula, and then substitute here f of x3. If it is 0, then that is the root, otherwise you have to repeat the process till you get the solution. And the order of the regular falsie method is also equal to 1. So now we are going to learn about the other method, which is secant method. See, this is similar to the regular falsie method, but only difference is now you don't have to check the condition which is f of x1 into f of x2 is less than 0. Means randomly you can take any point x1 x2. Therefore take any 2 points x1 x2, no need of checking f of x1 into f of x2 is less than 0. Only this is the difference. Remaining everything is same as the previous method, which is the regular falsie method, and then find the value of x3 by using the regular falsie method. So I have already told you, take any 2 random points which are the x1 y1 and x2 y2. So now draw these 2 points, or we can say draw this a line from these 2 points, and if you extend this line is going to meet the x-axis at a point which is, I am going to name it as the x3. So if you figure out the value of the equation, then keep y is equal to 0, you are going to get a point which is x3 is equal to x2 y1 minus x1 y2 by y1 minus y2, and then check whether f of x3 is equal to 0 or not. If it is 0, then definitely we are going to say it is a root of the f of x. Otherwise, you have to repeat the process till you get the solution. And the order of the secant method is 1.62. So I have already told you the order of the bisection method is 1, and the order of the regular Falsie method is 1, and the order of the secant method is 1.62. Now we are going to learn about the another method, which is the Newton-Raphson method. Suppose there is a graph f of x in such a manner. So now what I am going to do is, for this function f of x, I am going to consider a point which is x0, y0 on this graph. So let me assume the point is x0, y0. So now what I am going to do is, I am going to draw a tangent from this point to the graph. So if I draw a tangent and if I extend this line, it is going to meet the x-axis at a particular point which is called as the, let me assume this is x1. So now I want to know what is this point x1. Again, I have to repeat this process. Again, for x1 I am taking a point here x1. Again I am going to draw a line, straight line. Again it is going to meet the x-axis. Again I am repeating this one. Still I am going to get the exact solution of the function f of x. So therefore, the general equation of the root, which is x of n plus 1 is equal to xn minus f of xn by f dash of xn. So this is a general equation of the Newton-Raphson method to figure out the exact root of the function f of x, which is x of n plus 1 is equal to xn minus f of xn by f dash of xn. See, all the methods that we have learned is iterative method, means you have to do the process till you get the exact solution. So therefore now here you can substitute n is equal to 0, 1, 2 and it goes on. So n can goes from 0, 1, 2 and goes on. So therefore now then the order of this Newton-Raphson method is 2. So therefore I have already told you the order of the bisection method is 1, the order of the regular Falsie method is 1, and the order of the secant method is 1.62, and the order of the Newton-Raphson method is 2. So therefore now here this is the general equation of the Newton-Raphson method, which is x of n plus 1 is equal to xn minus f of xn by f dash of xn. Suppose always we have to assume a function f of x is a non-linear function is equal to 0. Means always the function, whatever the function we are going to get, we have to rearrange in such a manner it has to be always in a non-linear format. Then only you can solve this equation. Otherwise you can't solve this equation. So always try to make the function f of x in the format of non-linear function. To find f of x and also iterations converge to, then keep x of n plus 1 is equal to xn is equal to x in the iterative formula. See, to find function f of x and also iteration converges to, then keep x of n plus 1 is equal to xn is equal to x in the iteration formula. Suppose in the questions they are going to give you the iteration formula, means iteration function, and they want to figure out, see what this iteration is going to converge to what point, or we can sometimes they can ask the original function of the f of x for this iteration. They are going to ask. Then what you have to do is just see, I have already told you the function is going to have x of n plus 1 and also xn. So now what you have to do is you have to assume it is x of n plus 1 is equal to xn is equal to x. Then you have to keep this value x in the iteration formula and you have to do the simplification. Then finally you are going to get a solution, which is this is the exact function of the f of x, or you can say this iteration is going to converge to a point. That point also you can figure out. So now whenever x of n plus 1 is equal to xn minus f of xn by f dash of xn, as whenever n tends to infinity, means n tends to infinity means as we are going to do the iterations more and more and more, finally definitely we are going to get the exact solution. Or we can say the series is going to converge, which is x of n plus 1 is equal to x of n is equal to x. So therefore simply we can say we have to replace x of n plus 1 is equal to x of n is equal to x. So if you do replace this thing in the iteration formula, definitely we are going to get the exact root of the function f of x, or also we can simply say that that is called as the function of the f of x, and x is called as the root of the f of x. So the Newton-Raphson method fails if f dash of x is equal to 0, because I have already told you x of n plus 1 is equal to xn minus f of xn by f dash of xn. As f dash of x is equal to 0, so anything by 0 is infinity, so definitely we can't get a value which is infinity. So therefore we can say whenever the derivative of the function is equal to 0, then definitely the Newton-Raphson method is going to get failed. Always f of x is equal to 0. This is called as the standard form in which we are going to write the function f of x. See, suppose there is a function f of x is equal to x to the power of k minus a is equal to 0. So a function can be either in this format or f of x is equal to 1 by x minus a. So either you can write any function in this format also, or f of x is equal to 1 by x square minus b is equal to 0, means the functions can be either of these formats, which can be either in the x to the power of k minus a or 1 by x minus a or 1 by x square minus b, means all these things are the non-linear way. So therefore always the function should be always in a non-linear way, so therefore we can easily do the simplification. So now the absolute error at any iteration, as you are going to do the iteration one after the another, then I want to know what is the absolute error at any particular iteration, which is modulus of the exact value minus approximate value by the exact value. See, exact value you are going to get by the integration method, whereas the approximate value you are always going to get by the numerical method. So therefore we can say exact value minus, or we can say exact value, true value minus measured value by true value. So true value minus measured value by true value. So true value is also called as the exact value. It is always measured with the help of the integration method, whereas the approximate method is also called as the measured method or measured value. We are always going to get the approximate value with the help of the numerical method. Or we can say x2 minus x1 by x2, x2 minus x1 by x2, where x2 is the new iteration value, whereas the x1 is the old iteration value. So new value minus old value by new value. So either of any of this formula you can take in order to get the absolute error at any particular iteration in the Newton-Raphson method or any method which you are going to get prefer. Always exact value minus approximate value by exact value, means we can say simply true value minus measured value by true value. Exact value we are always going to get with the help of the integration method, whereas the approximate value we are always going to get with the help of the integration method. So therefore new value minus old value by new value. Always take the modulus sign. So numerical solution for ordinary differential equation. So now suppose up to now we have only seen those equations, up to now we have seen only those equations which are the f of x is equal to 0. But suppose if there is a differential equation, how to use the numerical methods in order to get the solution. See, the numerical solutions for the ordinary differential equation. The first method we are going to discuss is called as the Euler forward method, or it is also called as the Euler first order method. So listen carefully, this is also called as the Euler forward method or Euler first order method. Suppose the general format, which is dy by dx is equal to f of x comma y. This is the general of the function, which is dy by dx is equal to f of x comma y. Then y of n plus 1 is equal to yn plus h into f of xn comma yn. So y of n plus 1 is equal to yn plus h of xn comma yn. So now here h is called as the difference of the xn plus 1 minus xn, where n can goes from 0, 1, 2 and it goes on up to infinity. So therefore now we can say, if you know the x naught, y naught, and if the question they are asking what is the value of y1 at a particular value of xn, then you can use the Euler first order method to figure out the value of the value y1 with the help of these things. So therefore simply we can say by Euler forward method, which is also called as the Euler first order method, which is dy by dx is equal to f of x comma y, which is yn plus 1 is equal to yn plus h into f of xn comma yn. So therefore here h is always xn plus 1 minus xn, so n can go from 0, 1, 2 up to infinity, means if you know the value of x naught, y naught, then by using this formula for a particular value of x1, we can easily figure out the value of y1 for this differential equation. So now we are going to learn about the Euler backward method, or it is also called as the modified Euler method. So this is also called as the Euler backward method or the modified Euler method. So in the examination they are going to specify which method to use to get the solution. Suppose the function is dy by dx is equal to f of x comma y. Then for this, if you know the value of x naught, y naught, then what is the value of 1 for a particular value of x1, which is y of n plus 1 is equal to yn plus h of f of xn plus 1 comma yn plus 1. So you can see clearly here x and yn, but here x of n plus 1 comma y of n plus 1. and remaining everything is as same as the previous method. So therefore we can say h is equal to xn plus 1 minus xn, where n goes from 0, 1 to up to infinity. So therefore we can say clearly here, with the help of these things, Euler backward method, here just replace here x of n plus 1 comma y of n plus 1, and here in Euler forward method just go for the f of xn comma y. So now with the help of these things you can figure out the value of the y of n plus 1 at any particular value of x of n plus 1. So now we are going to learn about the another method, which is the Euler character predictor method. So Euler character predictor method. Then the formulas of this one, which is here, for the same function dy by dx is equal to f of x comma y, we have to do in this manner, which is yn plus 1 is equal to yn plus h into f of xn comma yn, same as the Euler forward method. Then here we have to go for the predictor. Then y of n plus 1 dash is equal to yn plus h by 2 into f of xn comma yn plus f of xn plus 1 comma y of n plus 1. So you can see clearly this is called as the prediction of the y of n plus 1 for a particular value of x of n plus 1. But this is a prediction, but you want to know the exact value, then you have to go for the correction. So therefore this is called as the correction. So therefore simply yn plus h by 2 into f of xn comma y1 plus f of x of n plus 1 comma y of n plus 1. So therefore whatever the value y of n plus 1 you got from this equation, substitute here and figure out this one, and simply you are going to get the first iterative value. And simply if you want to know what is the second iterative value, just replace this value by the first iteration value, and then you are going to get the second iteration. But if you want to go for the third iteration, just replace this one by the second iteration, then you are going to get the third iteration, and everything is same as the previous one. So therefore we can say repeat this process till the two successive iteration values are same. So therefore y of n plus 1 I is equal to y of n plus 1 I minus y. If these two iterations are same, then stop the process, and that is the exact value for the x of n plus 1. So therefore I can go from 0 and it goes on up to infinity. So therefore, or we can simply say that I can be from 2, 3 and it goes on. So if you take 2, it will become 1. So therefore it always goes from I is equal to 2, 3 and it goes on up to infinity. So therefore this is called as the Euler character predictor method. Means first we are going to predict the value, and then we are going to do the correction by iteration process till we are going to get the exact value. This is same as the Euler forward method, and then we have taken the yn plus h by 2 into f of xn comma y1 plus f of xn plus 1 comma y of n plus 1, and then do the iteration till we are going to get the exact value. Now we are going to learn about the other method, which is the Ranga method, or you can say Rangakura method. If it is a third order, then in the examination they are going to use solve this question with the help of the third order Rangakura method. Then we have to prefer these formulas. For the same function dy by dx is equal to f of x comma y, then the functions are y of n plus 1 is equal to yn plus h by 6 into k1 plus 4k2 plus k3. It's a very important formula, which is y of n plus 1 is equal to yn plus h by 6 into k1 plus 4k2 plus k3. So y of n plus 1 is equal to yn plus h by 6 into k1 plus 4k2 plus k3, where k1 is equal to f of xn comma yn, whereas k2 is equal to f of xn plus h by 2 comma yn plus k1. This is a k1 into h by 2, and similarly k3 is equal to f of xn plus h, comma yn minus k1h plus 2k2h. So therefore, see, with the help of these things, you are going to get the exact value of k1, k2, k3 and substitute here, and then do the simplification to get the value of yn plus 1 for a particular value of x of n plus 1. So therefore we can say the Rangakura method is a, suppose in the question they are going to ask you, by using the third order method of Rangakura, figure out the value of the y of n plus 1 for a particular value of x of n plus 1. If you know the value of xn comma yn for the differential equation dy by dx is equal to f of x comma y, then the formula is y of n plus 1 is equal to yn plus h by 6 into k1 plus 4k2 plus k3, where k1 is equal to f of xn comma yn, whereas k2 is equal to f of xn plus h by 2 into yn plus k1 into h by 2, and similarly k3 is equal to f of xn plus h comma yn minus k1h plus 2k2h. By knowing these formulas k1, k2, k3 values, then substitute in the above equation and do the simplification, then we are going to get the solution y of n plus 1. Now we are going to learn about the Rangakura method, or we can say the classical Rangakura method. In the question, if they are going to specifically, in the examination, if they are going to specifically mention that by using the fourth order Rangakura method, solve this particular differential equation dy by dx is equal to f of x comma y. If you know the value of x and yn, then what is the value of yn plus 1 for a particular value of x of n plus 1? See, suppose the formula for this one is y of n plus 1 is equal to yn plus h by 6 into k1 plus 2k2 plus 2k3 plus k4. See, for the previous third order means there are only 3 constant values k1, k2, k3, while but fourth order we are going to get 4 constant values k1, k2, k3 and k4. So now if you know the value of k1, k2, k3, k4, you can easily keep these values and figure the value of the y of n plus 1. So therefore now k1 is equal to f of xn comma yn, whereas k2 is equal to f of xn plus h by 2 comma yn plus k1 by 2, whereas k3 is equal to f of xn plus h by 2 comma yn plus k2 by 2, whereas k4 is equal to f of xn plus h comma yn plus k3. So like this we have to say, by using this we are going to get the exact values of k1, k2, k3, k4 and substitute here and do the simplification, then we are going to get the value of the y of n plus 1. So therefore, if in the examination they are going to specifically mention by using the fourth order Rangakura method, please figure out the value of the dy by dx for is equal to f of x comma y. If you know the value of xn comma yn, then what is the value of the yn plus 1 for a particular value of x of n plus 1? Then the formula is y of n plus 1 is equal to yn plus h by 6 into k1 plus 2k2 plus 2k3 plus k4. So k1 is equal to f of xn comma yn, whereas k2 is equal to f of xn plus h by 2 comma yn plus k1 by 2, and k3 is equal to f of xn plus h by 2 comma yn plus k2 by 2, and similarly k4 is equal to f of xn plus h comma yn plus k3. So with the help of these constants, if you know the value of k1, k2, k3, k4, substitute in this equation and do the simplification, then you are going to get the exact value of the yn plus 1 for a particular value of x of n plus 1. So up to now we learned the for a function f of x what are the exact roots, and also by using the for a differential equation, if you know the x and yn, then we also know what is the value of xn plus 1 comma yn plus 1 for differential equation. But now what we are going to do is, now we are going to do the numerical integration. See, sometimes it is not at all possible to do the absolute integration, then we are going to use the numerical integration to get the value. See, always the absolute integration is always going to give you the exact value, whereas the numerical integration is always going to give you an approximate value. So therefore, let me assume a function f of x with respect to f of x. So it is going to have the values x0, x1, x2 up to xn. For x0 means the value is y0, for x1 the value is y1, and for x2 the value is y2, and goes on up to for the value of xn the output is yn. Then here xn is equal to x0 plus n into h. See, xn is equal to x0 plus n, where n into h, where n is called as the number of intervals, means the number of, see this is a 1 interval, 2 interval, 3 interval, like this. The number of gaps between them is called as the number of intervals. It is called as the step size. Step size means the difference between the two successive x coordinate values. So therefore, h is equal to x1 minus x0 or x2 minus x1 or x3 minus x2 up to xn minus of xn minus 1. So like this we are going to do. So if you do rearrange well, we are going to get n is equal to xn minus x0 by h. So therefore, xn is equal to x0 plus n into h, where n is called the number of intervals between the x0 and xn, and where h is also called as the step size, which is the difference of the two successive x values. So now we are going to learn the 3 important formulas. With the help of these formulas, now we can figure out the integration of the function f of x for a particular point from x0 to xn. So trapezoidal formula, the trapezoidal formula is old for only those polynomials of a degree of 1, and we can even say it is order up to 3. So therefore, simply here the polynomial should have a degree of 1, and also the order of this trapezoidal formula is always equal to 3. So therefore now here, suppose it's the function f of x, we are going to do the integration from x0 to xn, means we are going to find what is the net area under the function f of x, absolute positive area. So x0 to xn f of x dx is equal to x0 to xn, where f of x is called as a y. So y dx is equal to h by 2 into y0 plus yn plus 2 times of the remaining values. So always take the first coordinate y value and the last coordinate value plus 2 times of the remaining coordinates between the y0 and yn. You have to take all these things. Then you are going to get the value of the integration from x0 to xn f of x dx is equal to h by 2 into y0 plus yn plus here 2 times of remaining coordinate values. Just do the summation. So here now let me tell you about the truncation error. T is called as the truncation error is equal to minus h cube by 12 into n maximum of the f double derivative of the c, where c is going to lie between the x0 to xn. It's a very important formula in the trapezoidal formula, which is truncation error is equal to minus h cube by 12 into n maximum value of the f double derivative of the c, where c is going to lie between the x0 to xn. Or simply here you can replace n is equal to here xn minus x0 by h. So if you replace n is equal to xn minus x0 by h, then you are going to get this formula. But I want to know only the absolute value. So absolute value of the truncation error is equal to s square by 12 into xn minus x0 into maximum of f double derivative of c. It is also called as the truncation error, or we can also call it as the with accuracy of. C is also called as the truncation error, or sometimes we are going to call it as the with accuracy of. It means that it is the determinant, or we can say the absolute value of the true value minus approximate value. So you can see clearly here it is always negative. So therefore, if it is a negative, it indicates that the approximate value is always greater than the true value. Then only we can say the truncation error is always negative. So whenever the approximate value is always greater than true value, then only the truncation error is always negative. So therefore, we can say clearly it is a truncation error determinant, means it is a modulus of the true value minus approximate value. True value we are going to get with the help of the integration method, absolute integration method, whereas the approximate value we are going to get with the help of the numerical integration. Now the another formula, which is the Simpson's 1 by 3 formula. Simpson's 1 by 3 formula, here we are going to use only for those polynomials with a degree of 2, or simply we can say this is also called as a Simpson's formula, and the order is up to 5. So therefore now here the formula of this one is integration of x0 to xn f of x dx is equal to integration of x0 to xn y dx is equal to here Simpson's 1 by 3 means it is h by 3 into y0 plus yn. See, h by 3 into y0 plus yn means initial value and the final value plus here plus 2 times of the y2 plus y4 plus y6. Take only the even parts, plus 2 times of the even parts, y2 plus y4 like this, and then 4 times of the remaining values, 4 times of the remaining y coordinate values you have to take here. So therefore here y0 plus yn plus 2 times of the, take only the even parts, which is y2 plus y4 plus y6 like that, and then 4 times of the, take the odd part, means the remaining values, whatever the remaining y coordinate values are there, you can take those values here. And do the simplification, you are going to get the numerical integration with the help of the Simpson's 1 by 3 formula. So truncation error for this Simpson's 1 by 3 formula, which is minus h to the power of 5 by 180 into n maximum value of the fourth derivative of the c, where c is going to lie between the x0 to xn. But you can replace n by xn minus x0 by h, and then you are going to get minus h to the power of 4 by 180 into xn minus x0 into maximum value of the fourth derivative of the c. So you can see clearly that truncation error is always negative. It indicates that the true value is always lesser than the approximate value. So therefore we can say the truncation error is always negative. Truncation error is also called as the with accuracy or of. Now we are going to learn about the Simpson's 3 by 8 formula, or we are going to use for this only of degree 3 equations, or we can say a polynomial of degree 3 are going to, with the help of Simpson's 3 by 8 formula, we can easily figure out the exact value of the integration of any function f of x. So integration of x0 to xn f of x dx is equal to integration of x0 to xn y dx is equal to here 3 by 8, so therefore h by 8. into y0 plus yn, same as the previous one, plus now here previously what we have did, which is here 2 times of the y2 plus y3 plus y4 we have taken. Now what we have to do is plus 2 times of, take the 3 times of the coordinates, which is y3 plus y6 plus y9 like this, plus 3 times of remaining coordinate values we have to take here. So therefore simply 3h by 8 into y0 plus yn plus here same here in the initial case, which is 2 times of the 2 times of values which are y2 plus y4, but here 2 times of the y3 plus y6, 3 values is 3 number, that the number is multiplied by 3, we have to take only those values, which is 2 times of the y3 plus y6, and here go for the 3 into y1 plus y2 plus y4, but in the previous case this is 2 and this is 4. So here it is a 2 and it is a 4 in the previous case. Here 2, take y2, y4, y6 and 4 times of the remaining values. But now what you have to do is replace, see, 2, keep 2 as it is, just replace here y3, y6. Means take here same as the, take number 3 now, take number 3 and here take the remaining values. So therefore here take y3, y6 like that and replace 4 by 3. Then you are going to get these functions. So therefore now simply just what we have did is we have taken y3 plus y6 and we have replaced 4 by 3 and remaining values you have to take here and do the addition. Then you are going to get the exact solution of numerical integration. So we have learned about the 3 methods, the trapezoidal rule and also Simpson's 1/3 rule and Simpson's 3/8 rule. So some more important points of the numerical methods we are going to learn, which is the analytic method always gives you the exact result and the numerical method always gives you the approximate result. This point I have already told you. Analytical method means the absolute integration is always going to give you the exact result, or you can say always the analytic method always going to give you the true value or the exact value, whereas the numerical method is always going to give you an approximate result. So we can say error is equal to, see, error is equal to the true value minus measured value. So true value is also called as the exact value, whereas the measured value is also called as the approximate value. But if you want to know what is the modulus of the error, which is the modulus of the exact value minus approximate value. If you want to know what is the relative percentage error, which is the error by the exact value into 100. So error by exact value into 100, it is called as the relative percent error. Relative percentage error means always the percentage should be always positive. So that is the reason we have to go for the modulus sign. And the order of the bisection method is 1. I have already told you 3 methods, which are the bisection method, regular Falsie method and also the secant method. In the bisection method, definitely we are going to go for the midpoint of the between a and b, and then we did the iteration to figure out the root of the function f of x. In the regular Falsie method, we have taken 2 points and the 2 points to satisfy the basic condition, which is the f of a into f of b should be always less than 0, and we drawn a straight line between them, and then we have figured out this line is going to meet a particular point which is with respect to the x-axis, and then we have determined that point, and then we have checked whether it is going to satisfy the root or not, and then we did the iteration to figure out the regular Falsie method. And similarly in the secant method also we did the same procedure as the regular Falsie, except you can take any 2 points. You don't need to go for the condition to satisfy, which is the f of a into f of b less than 0. So by this I have already told you the order of the bisection method is 1, whereas the order of the regular Falsie method is 1, and similarly the order of the secant method is 1.62. These are the very, very important things that you need to remember, because based on the questions have been already asked. For n points given, we can draw a polynomial of n minus 1 degree. See, you can see clearly, suppose with 2 points you can draw a straight line. So straight line as order 1. So therefore with the help of n points we can draw a polynomial of n minus 1 degree. For example, if you take a 2 points means n is equal to 2. So with the help of these 2 points you can get a straight line of equation of polynomial degree of 1. So therefore 2 minus 1 is 1. So that is the reason with the help of n points we can draw a polynomial of degree of highest power of n minus 1. Suppose there is a quadratic equation which is ax square plus bx plus c is equal to 0. Then the summation of the roots are the alpha and beta, and the summation of roots is the minus b by a, whereas the alpha into beta is equal to c into a. In case if you forgot the formula, which is alpha plus beta is nothing but summation of the rule, which is the negative minus 1 over to the power of 1 into the coefficient of the x to the power of n minus 1 by the coefficient of x to the power of n. So here n is 2, so x to the power of 2 minus 1 coefficient is x to the power of 1 coefficient, which is b. So b by a, coefficient of x to the power of 2, which is a. Similarly, alpha into beta, which is minus 1 whole square into coefficient of x to the power of n minus 2 by x to the power of n, which is x to the power of 2 minus 2, which is x to the power of 0, coefficient is c, and similarly the coefficient of x to the power of 2, which is a. So therefore simply we can say alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. The method with more order value converges to the exact root faster. The method with more order value converges to the exact root in a faster manner. See, the meaning of this one is, you can see clearly the order of the bisection method is 1 and the order of the regular Falsie method is 1, whereas the order of the secant method is 1.62. See, as the for a method, if the order is going to increase, means that method is very faster, means it is going to take a less time in order to get the value of the exact root. Means simply we can say that as the order is going to increase, we are going to get the exact root within a very small amount of time. Means simply it is going to take a less number of iterative steps to figure out the value of the exact root of a function f of x. And I've already told you that truncation error of the trapezoidal rule and also the truncation error of the Simpson's rule. Then here the truncation error of a trapezoidal rule is always directly proportional to the square of the edge, whereas the truncation error in the Simpson's rule is directly proportional to s to the power of 4, where h is called as the difference of the two successive x coordinates, or simply we are going to call it as the step size. So the truncation error for a trapezoidal rule is always directly proportional to L square, whereas the truncation error for a Simpson's rule is directly proportional to s to the power of 4. By using Euler forward method, we get proper rearranging. See, suppose if you are going to prefer the Euler forward method, suppose for a differential equation dy by dx is equal to f of x comma y. So if you know the value of for a x and if you know the value of y n, then what is the for a value of x of n plus 1, what is the value of the y of n plus 1? It's very simple, which is y of n plus 1 is equal to yn plus h into f of x n comma yn. So the important thing in this concept is, one of the important concepts, which is by using forward method we get a proper rearranging, which is y of n plus 1 is equal to some coefficient value into yn plus constant. Suppose y of n plus 1 is equal to yn plus h into f of x n comma yn. So keep f of x n comma yn in the f of x comma y and do the rearrangement, then we are going to get some equation in this format, which is y of n plus 1 into some constant value to yn plus some constant. So this is what in terms of the edge, this is going to go you, this value, this function will be in the terms of the edge. So the series will converge when the determinant, or we can say when the modulus of this coefficient value is less than 1, then only we can say this series is going to get converged to give you a finite value of the y of n plus 1. So it's a very important formula, which is here whenever the modulus of this coefficient of y of n, if it is lesser than 1, then only the series is going to get converged and it is going to give you a finite value for x of n plus 1. We are going to get a finite value of the y of n plus 1. So flywheel energy, the flywheel energy is equal to integration of 0 to 2 pi t of theta into d theta. See, work is equal to force into distance, whereas energy is equal to here integration of 0 to 2 pi torque into displacement, which is t of d theta into dt. Suppose there are the A, B, C, D. See, you can write any matrix A, B, C into like this also, like multiplication of this one into multiplication of this one, which is 1, 0, L2, 1, 1, or U1, 1, U1, 2, 0, U2, 2. So simply we can say, you can do the product of these two matrices, you can get the value of A, B, C, D, or simply here L1, 1, 0, L2, 1, L2, 2, or 1, U1, 2, 0, 1. Or you can say, you can replace A, B, C, D either in this format or either in this format. It is up to you which format you prefer, but still you are going to get the same result. Suppose there is a small example. Suppose a polynomial which is x cube plus x square plus x plus 1. So now for this polynomial I am going to do the division with respect to x plus 1, and then I want to know how to do the procedure. See here, first thing is here I want to get the value of x cube, but there is a x. So you have to multiply by x square, then only you can get the x cube. So x square into x is x cube, x square into 1 is x square. So do the subtraction, these two are going to get cancelled, then only thing is this you are going to get x plus 1. So here also x plus 1, here also x plus 1. So do it into 1. So therefore plus 1 is equal to 1 into x plus 1 is again x plus 1. Do the subtraction, we are going to get 0. So therefore x2 plus x square plus x plus 1 is equal to x plus 1 into x square plus 1 plus 0. So this p of x is equal to d of x into q of x plus r of x. So therefore you can see simply here the degree of the d of x is 1. So degree of the r of x should be always equal to 0. So 0 into x power of 0 is again 0. Suppose there is a function u with respect to x1 comma x2 is equal to 0, and similarly there is a function v with respect to x1 comma x2 is equal to 0. See, means u is a function of x1 x2 and v is also a function of x1 x2. Now I want to know what is the Jacobian matrix. What is the Jacobian matrix? So Jacobian matrix is here u v x1 x2. So dou u by dou x1, dou u by dou x2, dou v by dou x1, dou v by dou x2, and we can keep the points x1, x2 at a particular points, and then we can figure out what is the value of this Jacobian matrix. So the Jacobian matrix is equal to u v x1 x2. So dou u by dou x1, dou u by dou x2, dou v by dou x1, and dou v by dou x2. We can keep this point in this matrix, and then we can figure out the Jacobian matrix. So now the differentiation of the function f of x at a particular point, which is x0 is equal to, I have already told you, a differentiation is going to exist at a particular point x0 when it is going to satisfy the right hand differentiation and the left hand differentiation. If it is going to be same, then only we can say differentiation is going to get satisfied, otherwise it is not going to satisfy. But we are going to write in another form, which is the central difference formula, which is f of x0 plus h minus f of x0 minus h by the difference between these two values is 2h. So therefore dff by dx at x0 is equal to f of x0 plus h minus f of x0 minus h by 2h. This is called as the central difference formula. But here always the error will be directly proportional to the h square. I have already told you that truncation error for the trapezoidal is directly proportional to h square, whereas the truncation error for the Simpson's rule is directly proportional to h to the power of 4. So let at x is equal to 0. So let at x is equal to 0 with step size h1, the error is equal to a. See, let at x is equal to x0 with the step size of h1, the error is equal to a. And let at same x is equal to x0 with step size h2, the error is equal to b. Then in df by dx at x0, what is the relation between them? I have already told you the error is directly proportional to h square. So error for this one is a and error for this one is b. It is directly proportional to h1 by h2 whole square. So like this we are going to get the relation. I have already told you error is equal to exact value minus true value. So exact value we are going to get the absolute method, whereas the approximate value we are going to get by the, or we can say we are going to get the approximate value with the help of the numerical methods. So if you want to know what is the magnitude of the error, it is nothing but magnitude of the exact value minus true or measured value, which is, or it is also called as the estimated value. The real root of the equation 5x minus 2 cos x minus 1 is equal to 0 is, suppose there is a function like this, then I want to know what is the real root of this equation I want to figure out. See, let me assume, I have already told you, always you have to keep a function in the straight format, which is f of x is equal to 0, which is f of x is equal to 5x minus 2 cos x minus 1. So f dash of x is nothing but here 5 plus 2 sin x, because here 5x differentiation is 1 and minus 2 cos x differentiation is plus 2 sin x, because for a cos x the differentiation is minus sin x. So minus 2 minus is plus. So 2 sin x and the differentiation of 1 is 0. So f dash of x is equal to 5 plus 2 sin x. By using the Newton-Raphson method, x of n plus 1 is equal to xn minus f of xn by f dash of xn. So you can see clearly this is a nonlinear equation because there is a cos term. So because of that, this is always in the nonlinear format. So xn minus f of xn by f dash of xn. So now what we are going to do is, we know the value of f of x, we know the value of f dash of x. So make everything here and do replacement. So now I am going to keep an initial guess as x0 is equal to 1. Let I am going to assume the x0 is equal to 1. In cos, keep in radian mode. So always you have to keep in a radian mode inside it. So therefore you are going to get x1 like this, x2 like this, and x3. So you can see clearly 0.54, 0.54. These two are same. So therefore we can say the real root of this equation is 0.54, because if any two successive iterations are same, we are going to say that value as the exact root of the equation f of x. So always we are going to keep in the radian mode for a cost function. See, by default, Simpson's means 1/3 rule. See, in the examinations, they are not going to mention there is a Simpson's 1/3 rule, 1/3 rule, or Simpson's rule. It indicates that if they are in the question, they are going to mention Simpson's rule means it is by default, it means is Simpson's 1/3 rule, you can use it. So therefore, error is equal to exact value minus the approximate value. So therefore, error is equal to, in the Simpson's 1/3 rule, which I have already told you, which is minus s to the power of 5 by 90 into n, maximum value of the fourth derivative of the function c, where c is going to lie between the x0 to xn. This error value, if this error value is negative, it indicates that the approximate value is greater than the exact value. But if it is a positive, if it's positive, then definitely exact value is greater than the approximate value. That is the meaning of this one. Suppose there is a matrix 2 2 4 1, you can write like this. I have already told you in this format. This is called as the lower triangular matrix and this is called as the upper triangular matrix. So any matrix you can write in the product of the lower triangular matrix and also upper triangular matrix. So if there is simplification, we can get the value of the L11, L21, L22, and similarly U12 also you can easily figure out. If it's continuous and f of a into f of b is less than 0, then surely there is a root in a comma b. See, f of function should be always continuous, and if f of a into f of b is less than 0, then definitely it indicates that a root is going to lie between the a comma b. If a function is continuous and has root in a comma b, then surely f of a into f of b is greater than or equal to 0. Yes, if f of a into f of b greater than or equal to 0 indicates that at least one of them, a comma b, should may be root, and also a root may be lie between the f of a into f of b. If a function is a continuous and there is no root in a and b, then surely f of a into f of b is not equal to 0, or simply we can say f of a into f of b is greater than 0. If at least one of them is not a root, but there is a root between a and b, it indicates that definitely f of a into f of b is always greater than 0. But if there is in between them there is a root, and surely means sometimes it may be one of them, so then it has to be greater than or equal to 0. If there is no root means it is greater, it may be root means then it has to be greater than or equal to 0. By Newton-Raphson method, I have already told you xn is equal to xn minus f of xn by f dash of xn. See here, x0 xn we got, then x1 is equal to x0 plus delta x, means with the help of initial guess we have got the first iteration value, which is x1. So then what I am going to do is the new iteration is equal to old iteration plus some delta x. So x1 is equal to x0 plus delta x. So x0 is called as the initial guess, where delta is called as the correction to be added to x0 to get the value of x1. So this much amount of delta x that you need to add to the x0 in order to get the value of the x1. Simpson's 1/3 rule is used to integrate the function f of x between x0 is equal to 0 and x is equal to 1 using the least number of equal subintervals. The value of the integral is, suppose there is a question like this, which is by using the Simpson's 1/3 rule is used to integrate the function f of x between x is equal to 0 and x is equal to 1 using the least number of equal subintervals. The value of the integral is, here x is equal to 0 and x is equal to 1. We have to go for the less number of subintervals. The minimum number of subintervals for doing the integration is 2. So therefore, we are going to get one integration and one. This is a one interval and this is a one interval. So therefore, 0, 0.5, 0.1, 1. So therefore, now if you substitute x is equal to 0, we are going to get 1.8. If you substitute x is equal to 0.5 in this equation, we are going to get 1.95. And if you substitute x is equal to 1, we are going to get 2.4. Then what we are going to do is here, means here n is equal to 2, and also if you know the x0 xn, so n is equal to x0 minus xn by nh. So therefore, now definitely we can say we know the value of n, we know the value of x0, we know the value of xn. So we are going to get the value of h, which is difference of the two successive coordinates. So then the integration with the help of the Simpson's 1/3 rule, which is I have already told you, h by 3 into y0 plus yn plus 2 times of the that values which are the y2 plus y4, and here 4 times of the remaining terms values. So if we do the simplification, we are going to get the value of 2. So therefore, this is the exact value of this integration, or we can say approximate value by using the Simpson's 1/3 rule. Always distance is equal to speed into time. So the distance is equal to integration from t is equal to 0 to time, velocity into distance, time. So now we are going to solve the equations by using the Gauss-Seidel method. Suppose here they are given 3 equations and they are going to ask you solve this with the help of the Gauss-Seidel method. See, in Gauss-Seidel method, always the diagonal elements are always higher. See, always you have to rearrange the equations in such a manner all the diagonal elements are higher. So you can see clearly out of this all these coefficients this value is higher, and here out of all these things 3 values higher, and similarly out of all these coefficient values these values are also higher. So therefore we can say all the diagonal elements are very higher. So you have to write the equation in the format of all the diagonal elements are always higher. Then from here I want to know what is the value of x1. So do the simplification, rearrangement, we are going to get x1. From here figure out the value of x2 from this equation, and similarly from this equation figure out the value of the x3. So you got the value of x1, we got the value of x2, now we got the value of x3. So now I am going to assume the initial guess, the roots of all these 3 equations are 0, 0, 0. So initial guess is x to the power 1, 0. Means initial guess this is 0, 0, 0. So now what you are going to do is substitute all these things in this equation. In this equation, x2 is equal to 0, x3 is equal to 0, and do the simplification. We got the first iteration of the 1. And if you are going to go for the second one, you have to use the remaining values. Means whatever the values now we have got, we have to use them. Means replace here 0 by 1 and use those values to keep in here. So x1 is equal to now substitute here 1 and here new iteration value, but x3 is equal to old. So here you are going to get this value. Means whatever the values you are going to get, use them to do the iteration. Now you have to do this one till you are going to get the solution. So like this you have to go further and further, still you are going to get the same, still you are going to get the exact solution. So therefore this is the first iteration of the third one. Means again you have to go further, still you are going to get the solution of the exact for the equations. Suppose there is a question like this: the original differential equation of this dx by dt is equal to minus 3x plus 2 with x of 0 is equal to 1 is to be solved by using the forward Euler method. The largest step size that can be used to solve the equation without making the numerical solution unstable is. So what is the largest step size? Means h value that we can take, so that always we are going to get a stable result, means a finite value of the result. So what is that value we need to figure out, the maximum value we need to figure out. So then I am going to replace y by x and t by x, means replace x by y and t by x. We are going to get dy by dx is equal to minus 3y by 2, because this is a general format we are going to solve. So but here replace x by y and t by x, we are going to get y of 0 is equal to 1. I have already told you in the general equation of a forward Euler method, which is yn is equal to y0 plus h into f of xn comma yn. So for the I want the value of the first iteration, so substitute n is equal to 0, we are going to get yn is equal to y0 plus h into f of x0 comma y0. So here y0 plus h into, in place of f of x0 comma y0, we substitute this is f of x comma y, so substitute here f of x0 comma y0. So therefore minus 3 y0 plus 2. So do the simplification, we are going to get now this is y1 is equal to y0 into some coefficient plus 2 times of h. So this is called as the constant, this is the coefficient of the y0, or we can say old value. So this modulus has to be always less than 1, then only the solution of the differential equation is always stable. So the modulus of this value will be always less than 1, then only the solution of the differential equation is stable, or we can say simply we are going to get a final result. So the modulus means it can be either minus 1 or plus 1, so it can lie between this. So do the minus 1, so minus 2 less than or equal to minus 3 less than or equal to 0. Do cross multiplication with respect to minus 1, so 2 greater than 3 is greater than 0. So divide by 3, so 2 by 3 greater than h greater than 0, or simply we can write 0 less than h less than 2 by 3. So the maximum value of the hx is equal to 2 by 3. If you go more than this value step size, then definitely the solution of for the x of n plus 1 we are going to get a infinite value. So up to now we have learned only the third order Rangakura method and also fourth order Rangakura method, but now we are going to learn the second order Rangakura method formula also. Now we are going to learn for a differential equation, which is dy by dx is equal to f of x comma y. Then y of n plus 1 is equal to yn plus 1 by 2 into k1 plus k2. See, yn plus 1 by 2 into k1 plus k2, where k1 is equal to h into f of xn comma yn, and k2 is equal to hf into xn plus h comma yn plus k1. It's a very important formula, which is y of n plus 1 is equal to yn plus of into k1 plus k2, where k1 is equal to h into f of xn comma yn, whereas k2 is equal to h into f of xn plus h comma yn plus k2. It's a very important formula because most of the questions are being asked on this formula. That is the reason I am more specifically mentioning this formula, which is y of n plus 1 is equal to yn plus 1 by 2 into k1 plus k2, where k1 is equal to h into f of xn comma yn, and similarly k2 is equal to h into f of xn plus h comma yn plus k1. So if you want to know what is the percentage error, which is error by true value into 100. So error by true value is also called as the exact value into 100. So error is equal to exact value minus measured value, which is exact value minus measured value is also called as the approximate value by the exact value into 100. One of the real roots of f of x is equal to 0 lies in the interval. See, suppose there is a question like this. Only one of the real roots of f of x is equal to 0 lies in the interval a less than or equal to x less than or equal to b, and bisection method is used to find its value for achieving with an accuracy of epsilon. The required minimum number of iterations is, it's a very important question here, listen carefully. Only one of the real roots of the f of x is going to lie in the interval a to b, and bisection method is used to find its value for achieving with an accuracy of epsilon. The required minimum number of iterations is, means here we have to get a minimum error between the absolute value and the numerical value. That value is epsilon. So how many number of iterations are required to get that amount of accuracy, that amount of error? How many number of iterations are required to get that much amount of error? That is thing that we need to figure out with the help of the bisection method. So the formula is here: the modulus of the b minus a by 2 to the power of n should be always less than e, or we can say epsilon. So therefore modulus of b minus a by 2 to the power of n is less than e, means n is equal as a number of iterations. So these many number of iterations that you need to do in order to get an error which is less than the epsilon. So n can be always an integer, it cannot be a real value, means like point values. So therefore it has to be always a pure integer. So therefore if you do the simplification, by taking the log base e, like these things, if you do the simplification, then we are going to get in this format. So therefore n is called as the minimum intervals required, it should be always equal to integer. So if you take this many number of iterations, we are going to get an error, it is lies between the epsilon. If you go more than that, still error is going to get decrease. But if you want a minimum value, go for this minimum relation. So therefore the modulus of b minus a by 2 to the power of n should be always lesser than epsilon. Type 2 error in hypothesis testing is acceptance of the null hypothesis when it is false and should be rejected. It means that type 2 error in hypothesis testing is acceptance of the null hypothesis when it is false and should be rejected. Means if it is a false, means definitely you should reject it. If it is a true, means you should accept it. That is the meaning of the null hypothesis, which is the type 2 error in the hypothesis testing is acceptance of the null hypothesis when it is false and should be rejected. Simpson's third 3/8 rule is used to fit third order of polynomial. I have already told you here, this is going to go for the third order of polynomial, whereas the trapezoidal rule is used to fit for the first order of the polynomial, whereas the Simpson's 1/3 rule is used to fit for the second order of polynomial. These things I have already told you. This means trapezoidal rule is used for the first order of polynomial, whereas the Simpson's 1/3 rule is going to use for the fit for the, means give the exact value for the second order of polynomial, whereas the Simpson's third 3/8 rule is fit for the third order of the polynomial. Nothing specified, then just do Euler forward method with a step size of 0.1. See, in the questions they are going to give a differential equation dy by dx is equal to f of x comma y. They are going to give the initial condition x naught y naught, but they are going to ask you what is the y1 for x1. They are not going to mention any method. Then by default it indicates that use this method, which is the Euler forward method. Then you can easily figure out the value of the, if they are not given any steps also, you can assume which is 0.1. In a bisection method, after the n iterations, the difference between the exact root and the nth iteration root is at most 1 by 2 to the power of n. See, I have already told you, if you are going to do the n iterations. What is the error? What is the error between the exact root and the exact root and also the what is the exact root and also the this value which is called as the approximate root, which is an minus a naught is always less than or equal to 1 by 2 to the power of n. So therefore, in a bisection method after n iterations, the difference between the exact root and the nth iteration root is at most, means at most the maximum value, which is always 1 by 2 to the power of n. That is the meaning of this one. So not more than this it is possible. So therefore we can say this is called as the difference. So where a naught is called as the exact root and n is called as the nth iteration root. So the difference between the nth iteration root and the exact root is always less than or equal to 1 by 2 to the power of n. Where n is called as the number of iterations that you are going to do. So suppose there is a quadratic equation which is a square plus bx plus c is equal to 0, then the roots are minus b plus r minus under 2 base 3 minus 4 is c by 2a. It's a general equation. Error in Simpson's rule of numerical integration is much less than the trapezoidal rule for same numerical problem. So we can see clearly that truncation error in Simpson's rule of numerical integration is much lesser than the trapezoidal rule for same numerical problem. So you can see this is a very important point. Means if you take any equation, then if you are going to go for the two methods, which are the trapezoidal method and also the Simpson's method, then the error between the exact value and the approximate value which you are going to get with the help of the trapezoidal rule, this value is more than the Simpson's rule. So therefore we can say simply the truncation error, or we can say simply the error in the Simpson's rule which you are going to do the numerical integration is much lesser than going for the trapezoidal rule for the same numerical. Trial and error methods are also called as the iterative methods. I have already told you this iterative methods means it's basically a trial and error method. Means we are going to assume one value as a root and then we are going to do the iterative process, trial and error, till we are going to get the exact solution. If f of x is equal to p naught x to the power of n plus pn x to the power of n minus 1 up to pn, means we can say this is a polynomial of nth degree. If the coefficients are all positive, then the equation has no positive root. I have already told you the number of positive real roots should be always less than or equal to the number of sign changes in the f of plus x, means the number of sign changes in the f of plus x. If all the coefficients are positive, then definitely there will be no sign change. So therefore we can say is equal to 0. So therefore there will be no positive root, means there will be no positive, only there has to be negative root. If all the coefficients of the even parts of x are all one sign and the coefficients of the odd parts are of contrary sign, then the equation has no negative roots. So therefore we can say simply, see same thing I have already told you, just apply this property, which is the number of positive roots, the number of positive real roots is always less than or equal to the number of sign changes in the f of plus x. Similarly, the number of negative real roots are always less than or equal to the number of sign changes in the f of minus x. So by using this property we can easily figure out this rule. Similarly, if the equation contains only even powers of x and the coefficients are all of same sign, then the equation has no real root. So you can go for the same procedure also, we are going to get same thing here also. If the equation contains only odd power of x and the coefficients are all of same sign, then the equation has no real root except at x is equal to 0, same as the previous one. Simpson's rule is more accurate than the trapezoidal rule. I have already told you, because it is more accurate means Simpson's rule is always going to give you less error than compared to trapezoidal rule. Because of that reason only we are going to say that Simpson's rule is always more accurate when compared to the trapezoidal rule. And also I have told you, for trapezoidal rule the truncation error is directly proportional to x square, whereas for this one it is x to the power of 4. It is always less than 1, therefore we can say this is very higher error, means less error when compared to trapezoidal. The trapezoidal rule gives exact results while integrating polynomial up to degree 1. So that is the reason I have told you here we have to prefer that trapezoidal rule for only a polynomial of degree 1, but not more than that. Up to that only it can give the exact results, but not more than that. Simpson's rule gives exact results while integrating polynomials up to degree 3. I have already told you Simpson's rules can give you exact result only. You can go, means it can give you the exact results of polynomials up to 3 only, not more than that. Backward Euler's method is more stable than the forward Euler's method. See, it is more stable. See, backward Euler's method is more stable than the forward Euler method. It's a very important point here. You can write a matrix. This is a matrix we can write any matrix, any square matrix in terms of the product of the lower triangular matrix and also upper triangular matrix in this format. So now if it was multiplication and simplification, we can get the values of these unknown values in the L21, L31, L32, U11, U12, U13, U22, U23 and U33. We can get all these values with the help of these coefficients. The accuracy of Simpson's rule quadrature for steps of h is of the order of h to the power 4. I have already told you here the error, or you can say the error by using the Simpson's rule is directly proportional to h to the power 4, whereas the error by using the trapezoidal rule is directly proportional to square of the h, and you can say it is the order of h to the power 4. Similarly here, this matrix you can write in the product of the lower triangular matrix and also upper triangular matrix, and if it is simplification we can get these unknown values. So for solving simultaneous systems of linear equations, the following methods are available there. See, for solving the simultaneous systems of linear equations, the following methods are available there. I have already told you the linear equations, how to figure out the unknown values of the linear equations. There are so many methods. They are the matrix inversion method, Cramer's rule, Crode's and Döhler's method. It is also called as the triangulation method, Gauss elimination method, Gauss-Jordan's method, Gauss serial iterative method, Jacobian iterative method. So these are the different methods by this we can solve the linear equations. If the full column by the forward difference of delta to the power of n minus 1 f is a constant, if the full column by forward difference of delta to the power of n minus 1 f is a constant, then the polynomial function is of order of degree is equal to n. So it's a very simple thing here. If suppose if you are going to do the forward difference of delta f, then if delta to the power of n minus 1 f, if we are going to give a constant value for the full column, then we can say it is going to be a polynomial of order or degree is equal to n. So therefore, if the full column by forward difference of delta to the power of n minus 1 f, if it is a constant value, means that full column is of constant value, or we can say same value, then definitely we can say this is a polynomial of degree or order is equal to n. It's a very important point. So these are some of the important formulas which are very essential in order to do the problems. So I have told you all the important formulas in the numerical methods, and if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button, and whenever you upload a new video, the direct notifications comes on mobile. If any improvements in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care, and bye bye.